Hello again. Hello again. We covered the questions in the A part of this big document. Okay, and in the second round we will cover the questions at B part, and we will also have C part of the questions. Okay, let's start the questions at the B part. Okay. For the newcomers, let me repeat, I upload this document into Google Classroom. If you didn't, then now submit, I'm sorry, download the document, okay? And please take your own notes, write your own solutions on this document, okay? Let's start the questions at the part. For the first five questions, you have, let's say, 5 minutes, okay? Then we are going to discuss the solutions. For the first five questions, you have 5 minutes. Okay, for the newcomers, let me repeat. We are continue with the questions at B part. For first five questions, you have 5 minutes. Okay, 5 questions, 5 minutes. Okay, let's start. I guess you are done. Okay, let's start with the first question. With black box testing, the software tester does not or should not have access to the source code itself. Okay, we are talking about black box testing. Okay, and you are not telling the implementation in black box testing. That is white box testing. We will also solve some questions related to white box testing. Okay, in black box testing, you don't need to access to the source code itself. So the answer is here A, true. Okay, and if there is no objection or any other different idea, then let's continue. Okay. Uh, uh, okay, testing comes under black box testing. Okay, unit testing comes under white box testing. Okay, and functional and system testing comes under black box testing. So the answer is B. Okay. How about question number 3? Black box testing attempts to find errors in the external behavior of the codes in the following categories. Okay, incorrect or missing functionality, interface errors, errors in data structures used by interface behavior or performance errors, initialization and termination errors. F saying that all of above. So the answer is F. Okay, all of categories. Okay, comes under black box testing. Okay, in other ways, as written in the question, black box testing comes to find errors in all of these categories. Okay, if there is no objection, then let's continue with the question number 4. It is best if the person who plans and executes black box tests is not the programmer of the code and does not know anything about structure of the code. Actually, this is similar to the previous question. Okay, and the answer is 2. In some companies, actually, there is a separate test team. Okay, and these people are not from the developer teams. Okay, there is a separate testing team. Okay, and how about question number 5? Select four specification based or black box techniques from the following list. Actually, we see that only control flow graph here is related to white box testing. Okay, we are going to solve questions related to white box testing in the following problem sessions next week. Okay, and the others, boundary value analysis, decision tables, state transition testing, equivalence partitioning, are all specification based and or black box techniques. Okay, these are from your slides also. Okay. Okay, I received a question related to boundary value analysis. Actually, at C part, we have a boundary value analysis question, which is a previous final exam question. Okay, and before start part C, let's complete part B. Okay, and for remaining questions, Okay, for remaining questions in part B, question number 6, 7, 8, 9, 10, and 11. You have 6 minutes, okay? 6 questions, 6 minutes. Then we are going to start part C. Part C are from previous final exams, okay? Part B is previous quiz questions. Okay, for the newcomers, we are solving questions number 6, 7, 8, 9, 10, and 11. And you have 6 minutes, okay? Okay, I guess you complete your solutions. Let's start with question number 6. These two properties, although they appear to be similar, describe two distinct considerations. Okay, the first implies that each test case should involve as many different input considerations as possible to minimize the total number of test cases necessary. I am sorry. The second implies that you should try to partition the input domain let me take okay. The second implies that you should try to partition the input domain of a program into a finite number of equivalence classes such that you can reasonably assume that a test of a representative value of each class is equivalent to a test of any other value. Okay. These two considerations from black box methodology known as equivalence partitioning. This is from your slides. Okay, we have also a final exam question related to equivalence partitioning. Okay, and we have some input classes in equivalence partitioning, and each class we have actually infinite number of values, but in testing scenarios, we just select some values which represent those specific classes and perform our test only with those values instead of testing with all values from all classes. Okay, that is the logical equivalence partitioning equivalence classes. Okay, let us continue. Except when used on small programs, function testing is normally a black box activity. That is true. We have made similar discussions, conversations about these questions. Okay, in the first half. Okay, black box testing tries to look for errors in which of the following categories, and the answer is ABC, actually incorrect or missing functions, because black box testing is related to functional testing, related to functional activities, okay, interface errors and performance errors. Okay, and use cases can provide useful input to the design of black box tests of object-oriented software. Actually, you prepared your use case diagrams for requirement specification document. Remember that, and you observe this question is definitely true. And gray box testing is a combination of black box and white box testing. Actually, I am asked this question in a job interview. Okay, and they asked what is gray box testing. That is a combination of black box and white box testing. How about the last question of this part? While creating unique test cases, white box test cases are created and documented to validate the unique logic, okay? And black box test cases to test the unit against the specifications, okay? And then let us continue with the questions in the C part, okay? And okay, for questions 12 and 13, you have 4 minutes, okay? Then we are going to discuss these questions. Questions number 12 and 13, you have 4 minutes. Okay, let's start. Question number 12 is saying that what three attributes of a good software test, okay, and one could be has a high probability of finding an error, okay, because our aim is to find an error in testing, so that we want to fix those errors before submitting that product into the customer. Okay, our aim is just to find and fix those errors. Okay, and software tests should not be redundant. Okay, different test cases need to be related, different aims, different activities. Okay, they don't need to be redundant. Okay, and should not be too simple or too complex. Okay, these are possible three answers. Of course, we can extend this list. And let's continue with question number 13. Describe the differences between black box testing and white box testing. And black box testing involves testing the functionality of a software component without knowing the details of its internal logic. Okay, and remember that in black box testing, we have an input and we are observing the output. Okay, actually, we don't care about what goes on inside the testing activity. Okay, we really have a black box testing. We don't see the inside of the box, and we also don't care about the inside of the test. We are giving a specific input, and we are expecting a specific output. Okay, and white box testing involves testing the independent logic paths with full implementation knowledge. In white box testing problem session, probably next week, and we will cover some questions. We will calculate cyclomatic complexity. We will use some branch diagrams, okay? And you will see these independent logic paths in those diagrams. Okay, and now let us continue with the following questions. If you don't have any question up to now, okay, we are in part C, and we are continuing with question number 14 and question number 15. Okay, and you have again 4 minutes to take your own notes. Okay, 4 minutes. Okay, let us start. Describe okay. What was the question? Question number 14. Okay. What is equivalence partitioning as it applies to software testing? Actually, we discussed about it. A black box testing technique in which the input domain is divided into classes of equivalent data items. Okay. And test cases are derived from combinations of elements from each equivalence class. Exhaustive testing of all input domain values is not necessary. Okay, we have infinite number of values in classes, equivalent classes, but we just select some specific values from each equivalence class to represent the class itself and perform black box testing with only those values instead of all values in that equivalence class. Okay, that is the logic of equivalence partitioning in software testing. Okay, and let's continue. Question number 15. Black box testing is based on input classification. Discuss at most in a paragraph what this means. Okay. And black box testing is a functionality testing technique, and it examines the software system against requirement specification documents. Remember, you prepared your requirements for your term projects, okay? And black box testing ensures that the functionality meets what user expects. Each module is considered as a function f with some input x and expected to specific outputs. Okay, and we are given input value x. Okay, here our input value. I'm sorry for my handwriting. Okay, and we are expecting a specific output here. Okay, y here is our expected output. Okay. All done in black box testing is to check whether this output will be given or not. Okay, we are just checking the output itself. Okay, let me repeat. I mentioned actually at the beginning of the second hour of today's problem session. This is a really a black box here. Okay, we don't see the inside of this black box, okay? And we also don't care about what is going on, what is happening in this black box, okay? We just want to see the output, and we want to compare the output with the expected output. Okay, and we are dealing only the output itself. Okay, to comprehensively perform this, the relevant function domain x is partitioned into categories representing both valid and invalid members of x of the domain. Okay, and actually we have infinite number of x values, and we partition these values into some categories. Okay, several specific members from each category is selected to represent the relevant category and perform these corresponding testing. Okay, so pay attention here, please. We are just selecting some specific values from each category and perform the functional testing with those value only. Okay, we are not expected to perform functional testing with all of the values in all classes, okay? Because we have infinite number of values in classes. We are just selecting some representative values from each classes, okay? Let me clean the screen. Okay, and we have one more question before ending today's problem session. Okay, question number 16, and you have, let me say, 2 minutes. Okay, 1 or 2 minutes to take your own notes. Question number 16. Okay, let us start. You are a member of the system test team in a large-scale project. What type of test method would you prefer to utilize in your system-level test? Black box testing or white box testing? We are talking about system test, okay? And of course, that should be black box testing. And because team should concentrate on functionality of software rather than on code structure as in units. Okay, white box testing becomes infeasible. Infeasible in Turkish means uygulanamaz, gerçekçi değil. Since at the entirety of the code, the number of independent paths or conditions grow exponentially. So the answer here is black box testing. Okay, black box testing. Okay, and for the newcomers, let me repeat your project's homework number 5. Okay, you have approximately 10 days to complete this homework. Okay, and you have approximately 10 days. I announced it today. You are expected to prepare screens, graphical user interfaces, mockups for your project. No functionality on screens. Just copy these screens into a file and then submit the file into Google Classroom. Okay, and this is not implementation homework. And after this homework, the implementation period will start officially. Of course, you can start your implementation now, okay? And if you have any questions, please ask me your questions about problem session, about homeworks, about your projects, okay? If you don't have any questions, then I will take the attendance. Okay, I see there is no question. Then now I am taking the attendance. Please write your name and surname into chat box. Okay, and thank you very much for your participation, for your contribution to problem session. Okay, good luck at your new homework. Also have a nice weekend. Thank you very much. See you next week.